So this is my first lecture of circuit theory. You will get around 40 lectures. It will cover the whole circuit theory syllabus. In the first lecture, the lecture 1, I will discuss about the circuit elements. So the circuit elements are, we know that this is resistance. We are very much familiar with resistance, and we have inductance as well as we have capacitance. So we will discuss the properties of resistance, inductance and capacitance, how they behaves, and different waveforms. Today we will discuss about all those things. So first of all, we know resistance. Resistance is the resistor. Resistor gives resistance, we know that, and a resistance is proportional to the length of a conductor and is inversely proportional with the cross section of the conductor. And we are very much familiar with resistance, that's why I will spend less word for the resistance. As we know, resistance follow Ohm's law. So if we draw the voltage versus current curve, so what will happen? We'll get a voltage versus current graph like this. Okay, so this is a linear element. It's a linear element. It will start from the origin. It will not start from here or here. It will start from the origin. So this is a linear element, and we represent a resistor like this. And whenever a current is flowing through a resistance, there will be a power loss. The power loss is I square into R. So that is enough for the resistance. Right now we'll more concentrate on inductor and capacitor. Let's move on to inductor. This is an inductance. Inductance is given by an inductor. We generally represent the inductor like this fashion, though if you take a conductor like this, it has also a inductance of some Henry, but the value of the inductance for a straight conductor is very low. It has not any significance. That's why we represent it as an inductor. Whenever, so what is the property of an inductor? Now the property of an inductor is whenever a current is flowing through that inductor. Whenever a current is flowing, if the current is constant, it will behave as a passive element. It has not any effect to it. Whenever that current is try to change, say this current is 5 ampere, and suddenly it try to increase 5 to 10 for different reason. There we may increase the voltage, or we may decrease the load, increase the load. In that case also current may increase. So in that case, when current through the inductor try to increase, this time the inductor will behave as an active element, and it will not allow the change in current. So what is the property of an inductor? An inductor will always oppose the change in current through it. So an inductor give inductance, okay? Inductor will oppose any change in current. So what will happen whenever a current try to change? A voltage, a self-induced voltage will be there, which is proportional to the change in current. Okay. So whenever there is a change in current, a voltage will induced which will oppose the change in current through the inductor. Whenever when I will give the lecture of transient, I will discuss it again. Okay. Right now we have the voltage equation for an inductor. Now inductor is also known as charge storing element. It stores charge in magnetic field. You can read the field theory part for more information. Now whenever we have to find out the equation of current in terms of voltage, we can write it from here. Di is equal to 1 by L integral integration v dt. Okay, so say we have to integrate it. Say, sorry, 1 by L integrate 1 by L b into dt. Okay, so whenever we have to integrate the current, say we have to integrate over a period, say from t0 to t equal to t equal to say capital T, and let us assume at t0 current is I0 and at t the current is IT. So if we integrate it over from I0 to IT, respectively, so this is 0 to t dt. What we'll get? We'll get IT minus I0 is equal to 1 by L integration 0 to t v dt. So we can write the equation of current in case of inductor integration Now this I0 is the initial current. This I0 is the initial current due to the property of the inductance. We can get an initial current, so we always have to look for that value. In the next lecture, we'll solve few problems regarding the waveform. Say the voltage waveform of inductor is given, we'll find out the current waveform of the inductor, particular inductor. So this is the property of an inductor, and whenever the number of turn is increasing, the total overall inductance will also increase. Okay, so there is a logic, L is proportional to n squared, the number of turns squared. Okay, now what is the capacitance? We know that capacitance store charges over here. Okay, and it will not allow any change in voltage across it. Just like inductor will not allow any change in current through it, capacitor will also not allow any change in voltage through it. Let me describe it. We know a lot of things about the capacitance. So just let me focus about the current voltage relationship of capacitance. We know that charge across the capacitor is equal to Q into C into V. We know that. Now it is also known that what is current? Current is changing charge. It is dq dt. So if you put the value of Q over here, what we'll get? We'll get, so C. So this is the equation of a current through a capacitor. Now capacitor store energy in electric field between the two plates. Now we'll find out the equation of voltage from here. So again, we can write dV is equal to 1 by C I into dt. So again, if we integrate it, over a time period from 0 to t, we'll get the equation. I'm writing it straight away. So 1 by C integration I dt plus V0. So this is the initial voltage, we have to take care of it. Okay, so this is the basic concept of circuit elements. In the next lecture, we'll discuss about the waveforms. Thank you for watching my video.